Hello, welcome to the class. Today we are going to talk about hierarchical clustering. Hierarchical clustering is widely used in data mining and machine learning. It's very useful, but actually the concept is very easy to learn. It's not complicated and it's not difficult. Okay, before we get started, let's play a simple game. Imagine now you are a marketing specialist and you want to advertise your products to the customers from 8 countries. But I believe that you will not make 8 advertisements, right? Because it will waste too much money and time. So now you need to decide how many advertisements you need to make. That means that how will you group these 8 countries? You have 1 minute to prepare your answer. Okay, time is up. Now I will introduce my answer first and let's do some comparison. This is my answer. You can see that I divided all the countries into 3 big groups. They are America, Europe, and Asia. So my grouping is based on the location similarity. Canada and US, they are close to each other and they belong to the American, so they are in this group. And UK, France, Spain, they are in Europe. However, UK and France are much closer to each other and they belong to Western Europe. So I also set a subgroup here. And Spain, it belongs to the Southern Europe, so it's in another subgroup. But they all belong to the Europe, this big group. This situation is also happens in Asia. So now you can see that my grouping is based on the location, and your grouping may be based on the language. You might see Canada, US, and UK. Their official language are English, so you can divide them into the same group, and the other countries are in other different groups. So it means that grouping has different ways. Everyone has their explanation, has their principle to do the grouping. And this hierarchical structure is very similar with our today's topic, hierarchical clustering. So what is clustering? Clustering is a technique designed to group unlabeled examples based on their similarity to each other. You can choose to cluster based on different types of attributes like color, size, or type. Like my group before, my clustering is based on location, and you can base on language or other things. You can see these data points. There we have several data points, and now we cluster based on their location. So they will be grouped into 3 different clusters. When they are close to each other, they will put into the same group. Okay, so how can we use clustering? Clustering is important in data analysis for several reasons, including identifying patterns and structures within large data sets that might not be immediately obvious. So first example is the customer segmentation. Imagine you have 1 million customers and you have no idea what do they look like. What's their countries, where are they from, what's their age, what's their gender, and how to do the advertisement into this 1 million customers. So now you can clustering maybe based on their gender. You can make for the male, you can make advertisement like the car video or sports video, and to the female, you can make advertisement like the makeup videos. So the second example is the image segmentation. Now imagine we have a street view image, and in this image we can class them into different objects, such as which is the people and what is the building, which one is the car. And this will help us to class them. Okay, so in the clustering, we have different types. Hierarchical clustering is the first one, and it's also our topic today. Hierarchical clustering will finally create a hierarchy. Will finally create a tree-like structure. So you can see it has top-down and bottom-up approach. In the top-down approach, you will start from a point, and then you can split them. And finally, you can get a tree like this. This is the from top-down approach. Another one is also, we will go deep into this one, the bottom-up today. The bottom-up is we will have several data points, and for the bottom, we merge those similar ones. And then we go to the final cluster. We will cluster all the data set into one cluster, and that is the end. And for the second types, it's the k-means. In k-means clustering, we need to predefine how many groups we want. For example, if you divide the data into 2 groups, it will like this. And if you change the group numbers, it will produce different results. Okay, so for the hierarchical clustering, you will get a dendrogram, finally, like this. Okay, and then it's the algorithm. We will start with each point in its own cluster. So each point is a cluster. And then we identify the closest 2 clusters and merge them. So we can see in this picture, A and C is the closest one. So we group them together. And finally, after their merging, we found that DE is the closest one, the closest 2 clusters. And then we merge them. And finally, we have AC, B, and DE, these 3 clusters. And we find AC and B are the closest one. So we merge these 2. And then we finally get the dendrogram like this. AC, DE, and B and AC. We will stop this algorithm when all points are in a single cluster. Okay, let's do some hand-on exercise. We have dataset 1. It's very simple. Just each point has just one value. But in dataset 2, we will have 2 dimensions for each point. It's very easy to calculate the distance in dataset 1, I believe. You just need to subtract 2 values. However, in dataset 2, we have 2 dimensions. So now, how can we calculate the distance? The answer is we have 2 ways to calculate them. The first one is the Euclidean distance. We subtract the corresponding coordinate and then do the square and sum them up and do the square root. And the second one is the Manhattan distance. We calculate the absolute value for each coordinate and then sum them up. So here is the example for 2 points, x1 and x2. We subtract the first dimension and do the square, and subtract the second dimension and also do the square, and then sum them up and do the square root. For the Manhattan, we just sum the absolute value of the difference in each coordinate. So Euclidean distance is most commonly used. So we will use this as our example. Okay, so now I believe you already know how to calculate the distance. But there is another question. For example, when we merge 9 and 10 as a cluster, this is the cluster A. And we have another point is cluster B. So now we want to calculate the distance between A and B. Do we need to calculate the, so how can we choose the point, start point from A? Is it 9 or is it 10 or the average 9.5? So according to this problem, we have designed 4 linkage. The first one is the complete linkage. It will calculate all the points between cluster A to cluster B and then find the largest one, just like this. You also calculate this, but you will find this is not the largest one. So then you find these 2 dots. They are very far from each other, so you take the distance of these 2 points as the cluster distance. For a single linkage, you also calculate the points from cluster A to cluster B, and then you find the smallest one, just like this. So you choose this distance as the cluster distance. And the average is to calculate all the points from cluster A to cluster B, and then take the average. So in this distance, we will have D1, D2 to Dn. And then the cluster distance is the average of all this distance. The fourth is the central. It's first to find the cluster A central and the cluster B central, and then to calculate the difference, calculate the distance between central A to central B. So the average is to do the average later, and the central is to do the average first and then calculate the distance. These are the 2 primary difference between average and central. Okay, so in today's example, we will use complete linkage as the example. Let's do the calculation. So we'll take the dataset 1 as our example. This is round 1. And we write all the data point here. Okay, so the diagonal is the point to themselves, so it's all 0, so we can skip them. And also it's symmetric, so we can ignore this part, and we only need to calculate the right part. Okay, so the distance between between 3 and 10 is 7. This is 2. This is 11, 6, 5, 4, 1, 9, 4, and 5. Okay, so now we found 1 is the closest, so we merge 9 and 10. Okay, round 2, 3, 9 and 10, 5, 14, 3, 9 and 10, 5, 14. Okay, we also skip this part. And when we calculate the distance between 3 to this cluster, we choose the largest distance, so we choose 7. This is 2, this is 11, and this cluster to 5, 9 and 5 is 4, 10 and 5 is 5, so we choose 5. And this one we also choose 5, is between 9 and 14. And then it's the 5 and 14, so it's 9. And also during this distance, we need to find the smallest one, is 5 and 3. So round 3 will be 3 and 5, 9 and 10, 14. Okay, so now it's a little bit complicated. From the 3 and 5 to 9 and 10, from these two clusters, we calculate 3 to 9, 3 to 10. This is 6, this is 7, and 5 to 9, 5 to 10, this is 4, this is 5. So we can see 7 is the largest one, so we set 7 as their distance. Okay, so 3 and 5 is clustered to 14. We also choose 14 to 3, 14 to 5. This is 11, this is 9, so we set this is 11. Okay, so 9, 10 to 14 is the same. We choose 9 to 14 is 5. Okay, so now this one is the smallest one. And the final merge is the 9, 10, and 14. So let's draw the dendrogram. Then a dendrogram. So we start from 9 to 10 because they are the first one. And this is the distance. So their length is 1 because their distance is 1. And then it's the 3 and 5. Their distance is 2. So here is 2. Okay, so then it's the 14. It will be merged to 9 and 10. So their distance is 5. So we need to set, oh, it's too much, like this. And the final one is the the final one is to merge these two and these two, this cluster to this cluster. So you can see that their distance, their largest distance will be shown in between 14 and 3. So their distance is 11. This one. So we'll draw the distance like this, and I hope this will be represent 11. Okay, so this is our final dendrogram. Okay, so for the second data set, the algorithm is very similar. The only difference is the calculation on the distance will be a little bit complicated than data set 1. So let me take an example. It's the same to write all the data as a matrix. And then you need to calculate the distance between AB and AC and AD, BC, BD, and CD. And in the round 1, you need to choose the smallest distance in this group, and then merge these two dots. Okay, so now let's take an example how to calculate the distance between AB. So we can see AB is 1, 2, and B is 3, 2. Okay, so now we use B's first dimension to subtract the A's first dimension to the square, and the second dimension to the square, and then do the square root. This is how we calculate the distance between AB. So these are all similar with how to calculate the distance on other dot. Yeah. So these are all the example of showing how to calculate the distance and how to use the complete linkage. Actually, there are no certain standard like which linkage you need to use, or what kind of distance calculation method you need to use. And you just need to compare different results and finally to see which one is the ideal one. And for the final clustering, you can cut them into different lengths. For example, if you cut here, you will have final 2 cluster. This is 1, this is 2. Okay, but you can also cut here, and then you will got 3. This is 1, this is 2, this is 3. So how to cut this cluster is also decided by you. So clustering is very interesting. It doesn't have a standard answer. It can all decided by you. The method, the final result, final decision is all decided by the data scientist. Okay, this is my today's presentation. Thank you for listening.